then the deviation between these two is always greater than epsilon, where epsilon is greater than 0. It's a positive value. Epsilon is a positive value. Are getting the difference between absolute difference between k by n and p is always greater than epsilon. This is an event. For this we are going to apply probability. This probability is always less than pq by n epsilon square. This is the Bernoulli theorem or law of large numbers. So I'm going to write the statement. Let A denote an event. Let A denote an event whose probability of occurrence of occurrence in a single trial is P. If K denote the number of occurrences of A, the number of occurrences of event A in an independent trials then the probability P of K by n minus P greater than epsilon. This probability less than PQ by n epsilon square, where Q equals to 1 minus P. We have to prove this. So before prove this, we need some prerequisites. The prerequisites are: first one, summation over k equal to 0 to n k p n k is equals to np. Second one, summation over k equal to 0 to n k square p n k is equals to n square p square plus npq. So these are required to prove this. So the given event is k by n minus p greater than epsilon. This can be also written as k minus np mod greater than n epsilon. Let us say this, let us square on both sides, then we get k minus np whole square greater than n square epsilon square. Let this equation be 1. Let us apply summation on both sides. Summation over k equal to 0 to n p and k. Anyway, this is equals to 1 on both sides. Sum of the probabilities is equals to 1. Anyway, I am going to apply on both sides. On the right side, there is no k. Right side is n square epsilon square. So even though it is applied, no problem. So left side, summation over k equal to 0 to n k minus np whole square p and k. This is on the left side. On the right side, n square epsilon square summation over k equal to 0 to n p and k. Sum of the probability is equals to 1. There is no big effect. There is no big effect on the right side. It is equals to 1. Finally, summation over k equal to 0 to n k minus np whole square p and k greater than n square epsilon square. Let us say this equation is 2. Okay. Now let us consider the LHS of equation 2. Consider LHS of equation 2. So what is on the left side? It is summation over k equal to 0 to n k minus np whole square p and k. So let us apply the a minus b whole square formula. K equal to 0 to n k square plus n square p square minus 2np p and k. Let us distribute this summation. So what we get? Summation over k equal to 0 to n k square p and k plus n square p square summation over k equal to 0 to n p and k minus 2np summation over k equal to 0 to n p and k. Yes. Yes, Chepama. Latisha. You raise your hand. Already we have seen the prerequisites. According to that, this is n square p square plus npq, and this is equals to 1, and this is equals to 1. Sum of the probabilities equals to 1. So let us write what we have got: n square p square plus npq plus n square p square into 1 minus 2np. I think this is 2nk, right? 2npk. This is k. Then this becomes np. This is np. And then it is n square p square. So in that case, n square p square minus 2 n square p square gets cancelled, and it leaves us NPQ. So the left side of the equation 2 is NPQ. Let us say this equation is 3. Let us again consider LHS. We are going to write the LHS in another way of equation 2. Consider LHS of equation 2 again. This time I am going to split this k equal to 0 to n, k minus np whole square p and k. This is equals to, I am going to split into two intervals. One is k minus np mod less than n epsilon, k minus np whole square p and k. Second one, k minus np greater than this, let me put equal and here an epsilon, k minus np whole square p and k. So we have to prove that k by n minus p greater than epsilon. We want that event. So under that case, I'm going to neglect this because I don't want this one. Let us neglect it. So when you neglect this, the right side value becomes smaller. It becomes low. So in that case, we can put greater than symbol. Okay. K equal to 0 to, and I'm interested in k minus np mod, okay, greater than n epsilon. So this becomes summation over k minus np greater than n epsilon k minus np whole square p and k. Right. Now from equation 3 we can write this as NPQ greater than summation over k minus np greater than n epsilon k minus np whole square p and k. I'm rearranging this way, summation over k by n minus p mod greater than epsilon k minus np whole square p and k less than npq. Okay, now we can write this from equation 2. From equation 2 we can write it as summation over k by n minus p greater than epsilon n square epsilon square p and k less than npq. Here one n gets cancelled. Finally we are getting summation over k by n minus p greater than epsilon p and k less than pq by n epsilon square. The left side is the probability of this is equal, the left LHS is equivalent to written as It is the probability of k by n minus p, it's small, greater than epsilon, is less than pq by n epsilon square. Okay, so this way you have to prove. So far it has not given in the previous papers, but is it in the syllabus? I have put in the end. So this is about Bernoulli theorem. So where we use this probability, that is important. Significance. See, the probability of getting a heads is 1 by 2. Okay, this is single trial. Now I am going to perform an independent trials so that I want to get 1 by 2 only. అంటే ఎన్నిసార్లు టాస్ చేస్తే నాకు ప్రాబిలిటీ 1/2 వస్తుంది. ఓకేనా, దట్ ఐ వాంట్. ఇక్కడ ఎప్సిలాన్ ఎంత ఇచ్చాడంటే ద డీవియేషన్ 0.1 ఉండొచ్చు అని ఇచ్చాడు. నాట్ ఓన్లీ దట్ హీ హాస్ గివెన్ ద ప్రాబబిలిటీ ఆఫ్ దిస్ డీవియేషన్ ఈస్ గివెన్ యాజ్ 0.3 ఇచ్చాడు. అంటే ఎన్నిసార్లు టాస్ చేస్తే యూ గెట్ ద ప్రాబబిలిటీ 1/2. again you get 1/2. that we have to put. So 0.3 less than n what we call pq. I'm applying the formula 1/2 into q is also 1/2 by n epsilon square 0.1 square. So n less than 1/4. So this 1000 by 3 and n less than, how much is this? 1000 by 12. 12 8 ja 960 8 40 12 3 ja 36. Okay, 83.3. So what is the meaning of this? Maximum you can toss 83 times to get the probability of 1/2. That is why this is called as law of large numbers. Sometimes you require 500 times, sometimes you require 1000 times. You have to repeat the experiment to get the probability 1/2. Okay, if you go as many times as you get the closer probability. Okay, so here you have to toss the coin maximum 83 times. Okay, so less than got, I can say that n equal to 83. So any doubt in this class? Oh, already it is 8. Here ఇదేంటంటే ఇప్పుడు ప్రాబిలిటీ 1/2 అని ఇచ్చాను నేను. సింగిల్ టాస్ లో ప్రాబిలిటీ 1/2 వచ్చింది. నేను మళ్ళీ రిపీట్ చేయాలి. సెకండ్ టైం రిపీట్ చేస్తే 1/2 రావచ్చు, రాకపోవచ్చు. అవునా? థర్డ్ టైం చేసినాను, రావచ్చు, రాకపోవచ్చు. ఇంకోసారి చేశాను, యు ఆర్ నాట్ గెటింగ్, బట్ యు ఆర్ గెటింగ్ అప్రాక్సిమేట్లీ 1/2. 1/2 కాకుండా నీకు జస్ట్ 3/4 లైక్ అలా వస్తుంది. ఎన్నిసార్లు రిపీట్ చేస్తే యూ గెట్ దాట్ 1/2 ప్రాబిలిటీ. నీకు ఎగ్జాక్ట్ 1/2 రాదు, బట్ ఇఫ్ యూ రిపీట్ యాజ్ మెనీ నెంబర్ ఆఫ్ టైమ్స్, ఓకే, దెన్ this repeated probability will come close to the p 1/2.
Okay, sir.
So that is why it is also called as law of large numbers. సింపుల్ గా చెప్పాలంటే మీరు ల్యాబ్ లో ఎక్స్పెరిమెంట్ చేస్తుంటారు కదా.
Yes, sir.
ఇది మీకు ఇంటర్మీడియట్ లో ఫిజిక్స్ లో కెమిస్ట్రీలో చేస్తుంటారు. ఒకటే ఎక్స్పెరిమెంట్స్ ని మెనీ టైమ్స్ చేసేసి దాని యావరేజ్ తీసుకుంటారు. వై? టు గెట్ అక్యురసీ. అవునా?
Yes, sir.
Yeah, here also we repeat an experiment many number of times to get that required probability.
Okay, sir.
Okay.
Okay, sir.
Yeah. So any doubts? I have posted the previous question papers along with solutions. I think last 5 years you go through them. Okay. అందులో ఆ క్వశ్చన్స్ ఆ సొల్యూషన్స్ లోనే you have the derivations of PDF, CDF derivations of different random variables. Gaussian random variable, Poisson random variable, binomial random variable. All random variables are there. You can go through them and go through the solutions also. Yes, Sia, tell me the absentees numbers.